Hi, this is Sheshanan. So I'm just going to design one application to display today's date on 6-digit 7-segment display in embedded C program. So I'm just developing source code by using Keil microvision, and which is simulated using Proteus tool. So I'm just using Keil microvision. The existence project I am closing. Now these are the steps you need to follow to create the project. Select project tab and choose the option new microvision project, and create your own folder on a specific drive, which is my folder date, and here I am just giving as source code name and project as today's date. Just give your project name and choose the option save. And this is the window which helps us to select the microcontroller from different manufacturers. So you can work with any device using this Keil microvision, whatever the list they are providing here. Now I'm going to choose a specific manufacturer, is Atmel, and click the plus mark. It can show the devices present from this manufacturer. Now I'm selecting a microcontroller which is DD.MM.YY. After device selection, click on OK. Now this is a startup code warning. You can click on yes or no, there is no problem. Now I am taking no option. So up to now you created a project with a specific target device which is Atmel AT89C51. To develop your source code, you need to open editor window. For that, go file tab and choose the option new. So this is the text editor. Here you can type your program, and before typing this program I'm just looking this, save this file. Again go file tab and choose the option save, and the file name you can give it as same name as project, or else you can go with a different name also. So now I'm taking today's date, but the extension is .c. So whatever the language you are using to develop this source code, you need to go with that specific extension. Save your file name with .c extension here. Click on save. Now you can type your program. And as per hardware, whenever you are using 6-digit multiple 7-segment, you need to manage 6 common pins, so which are connected with port 3. These are the segment common pins. I am just declaring with user defined name as segment 1, segment 2, like this. So I'm just copying this name and I will change the numbers. And segment 3, which is 3.2. So I'm just using 6-digit 7-segment to display date, month and year as 2 digits. So I'll write this program name. DD.MM.YY format by using 6-digit multiple 7 segment. So these are the declarations I'm doing with this hardware, and now I'll declare one function is delay, and data lines which are commonly connected with port 2. So this is the main. The comparison starts from here, and default segment logics I'm changing to 0. Generally all IO pins default logics are 1s. So even you need to take one more segment from declaration. This is segment 6. So here, which allows to all common pins are commented. Now I'm taking infinite loop, which is while of 1. The first segment common pin I'm activating by assigning logic 1 for this. Now, as long as today's date is 29, this program allows to display 29.07.19, so that I need to fix the values to the port. So I'm just activated first common pin, and what value I'm expecting on first digit 2. So the 2 value you can display it from common anode lookup table. So these are the hexa values you need to use. Because of common anode, the segment common pin is connected to VCC. You are looking to activate that segment from 7 segment chip, so you need to assign logic 0. So one end is already VCC, you need to assign zeros to activate your segment. Now the 2 equivalent value is A4 from this table. The same value I am assigning to port, so that from first segment I can expect 2 number, and the delay I am calling between each segment switching. Again, the second segment I need to enable by disabling your first segment, because data lines are common, you need to manage your common lines. And from second digit I am expecting 9 with dot. So just again open your table. What is the 9 equivalent value? But within this 9, even I am expecting dot. So you are looking to turn on dot from Ember. You need to make this H as 0, so that you'll get 9 number with dot. It become as 10H. So the value here I am taking 10. So in embedded C I need to write 0x. So this is 2, and the second number is 9 with dot. And again I'll apply delay between each segment. The second segment common line you need to assign logic 1. Now the third segment I need to disable second segment first by assigning logic 0. The third segment I am just activating by assigning logic 1, and the equivalent value here 0. 0 equivalent value is C0 from table. This is the value for 0, and here I'll apply delay. And after delay, again I'll disable third common pin by assigning logic 0. The fourth common pin which is activated, and the value here I am expecting from port as 07, 7 with dot. So 7 with dot, even I need to turn on H, so that the value is 71H, 78H. So this is 7 with dot. I'll apply delay. In the next segment I'll disable 4th segment as 0 and 5th segment as 1. And what is the value here? I'm expecting 1. So what is one equivalent value? F9. So F9 to your 7th segment. And apply some time delay. Now the 6th segment I need to enable by disabling 5th segment. At this port, what is the equivalent value? I am expecting 9. So 9 without dot, so that value is 90H. In the segment 6 I need to disable because this is in while loop. So this program allows to display today's date as 29.07.90. What about delay definition? The delay function, so I'm just using for loop, self for loop concept with V1. So this value I'm taking it as to some 2000. So this is my source code to display today's date by using 6-digit common anode display. To compile this program, you have to follow these steps. Choose target 1 from project workspace window and click on this plus mark. You'll get source group 1. Select source group 1 and right click and choose the option add files to source group 1. My file name is today's date. Select it and add. Once the file is added, you'll get plus mark here. So after adding this file, go project tab and choose the option build target, so that it will show the errors and warnings present from this program. So I have multiple errors. With simple semicolon. This is a declaration for delay. To link this program with hardware simulation, you need to create hex file. To create hex file, these are the steps you need to follow. Select target 1 and right click and choose the options for target 1 and set your oscillator frequency as 11.0592 and highlight this use on chip ROM. Click on output tab and create hex file. After giving all these options, go project tab and build target. So this allows to display today's date. Now go with hardware design by using Proteus tool. So now just choose your components, whatever you are looking. I selecting P. P means pick the devices from library. Select your controller and double click it. Now I am looking for 7 segment 6 digit. Just read the description and select it. Now I am looking for 6 digit common anode display. So place your controller, design and place your display unit, which is 6-digit common anode display. And according to source code, the segment lines which are connected with port 3 and data lines are connected with port 2. So I'm just connecting common lines with port pins. So according to source code, I just connected all common pins of 7 segment which are connected with port 3.0 to 3.5. and data lines which are connected with port 2. So I'm just doing my hardware connections as per source code. So after designing your circuit, then double click on controller. It will ask for program file, which program you are looking to link. So which already saved in my D drive, which is date folder. So this hex file you need to link with your simulation design and change your oscillator frequency as 11.0592 and now play design. So still I am getting some flickering with these segments, so I can change my delay value so that switching delay should be very less. So I just made it 1000. If you do any modification, save this and build it. Now let's see the response from design, which is as 6 digits with date and month and year. Thanks for watching. This is the simulation.